You know how large language models can sound like a genius one second and then just completely make something up the next? Yeah, it's a huge problem. But what if we could teach them to stop and think, to actually check their facts and then act? Well, let's dive into the REACT framework because it's a fascinating approach that does exactly that.
So here's our game plan. First, we'll unpack the big dilemma that these language models are facing. Then we'll look at the two old-school approaches and see where they fall short. After that, we'll introduce REACT itself, watch it solve a problem step by step, and finally, we'll talk about why any of this really matters for the future of AI. All right, let's kick things off with the core issue, the LLM's dilemma. Why do these incredibly powerful models so often stumble when a task gets a little complicated and needs to interact with the real world? The researchers behind REACT came up with a perfect analogy: cooking. Think about it. When you're in the kitchen, you don't just mindlessly follow steps. You think, okay, veggies are chopped. I should probably heat up the pan now. Then you act, you turn on the stove. You observe, oh, the oil's smoking a bit, and you adjust the plan. It's that constant back and forth between thinking and doing that actually works. And that, right there, is the million-dollar question. Can an AI do the same thing? Can it blend that internal monologue, that reasoning, with real-world actions to solve problems without tripping over itself? Honestly, this has been a massive hurdle for a long time. So before REACT, people generally tried to tackle this in one of two ways. You either had a thinking-only approach or an acting-only approach. And as you're about to see, both of them had a pretty critical flaw. On one side, you've got reasoning only. Think of things like chain of thought, where the model kind of thinks out loud. The problem is, it's all happening in a black box. It never actually checks its work with the outside world, and that's how you get those confident but totally made-up facts we call hallucinations. Then, on the other side, you've got acting only. This model can do things like search a website, but it has no high-level plan. If something goes wrong, it doesn't know how to rethink its approach. It just gets stuck. And check this out. Here's a perfect example of where that thinking-only model goes wrong. It's asked about the Apple remote. It reasons its way to an answer, but then it just hallucinates that an iPhone could control the original program the remote was for. It sounds plausible, but it's completely wrong because it never took the simple action of looking it up. And here's the flip side. The acting-only model correctly figures out it needs to search for front row. But the search fails and boom, it hits a brick wall. There's no internal voice saying, that didn't work. Let me try front row software instead. It just gives up. Total failure. So you've got one model that makes things up and another that gets stuck. This is where REACT just changes the game entirely. It says, why choose? The real power comes from combining thinking and acting into one seamless loop. So what is REACT, really? It's a new way of doing things, where the model generates a thought, then an action, then a thought, then an action, back and forth. The thoughts guide what to do next, and what happens next feeds back into the next thought. It's a really smart, continuous cycle. And it all breaks down into this really simple but powerful loop. First, it thinks, generating a little plan for itself, like, okay, first I need to find out X. Then it acts on that thought. It goes and searches a database or whatever it needs to do. And finally, it observes the result of that action. That new information gets fed right back in, and the whole think, act, observe loop starts all over again. Okay, the theory sounds great, but let's actually see this thing in action. We're going to take that exact same problem that stumped the other two models and watch how REACT just breezes through it. So here's that tricky question again. Aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with? You can see why this is tough. It takes a few steps and some outside knowledge to figure out. And right away, REACT starts with a thought. It doesn't just guess. It has an inner monologue, and it forms a clear, simple plan. First things first, I need to figure out what program we're even talking about. So then it acts. It runs the search it just planned. And look at that observation. It gets back a critical piece of the puzzle. The program is called Front Row. No guesswork, no hallucinations, just a cold, hard fact from the real world. Now, this is the really cool part. It thinks, okay, next step is to search for front row. It acts, but just like the other model, that search fails. But here's the difference. REACT doesn't give up. It observes the failure and has another thought. It says, okay, that didn't work. Let me be more specific and try again. It adapts its plan on the fly. This is huge. And because it adjusted its plan, the next action, searching for front row software, works. Now it gets another key piece of information back, It knows exactly what front row is. In its final thought, it puts all the pieces together. It observed from that last search that front row could be controlled by either the remote or by keyboard keys. Since the question asked for something other than the remote, it correctly figures out the answer must be keyboard function keys. And just like that, task complete.
I mean, that's a pretty amazing demonstration. But you might be wondering, does this really make a difference in performance overall? Well, let's take a look at the results and what this actually means.
This chart says it all. In these really complex virtual tasks, the old ACT-only model had a success rate of about 45%. React, with its ability to think and adapt, jumps all the way up to 71%. I mean, that is a gigantic leap in performance. It proves this isn't just some small tweak. It's a fundamental improvement in the AI's ability to solve problems. And it's not just in virtual worlds. On Hotpot-QA, which is a really tough benchmark for question answering, you see the same story. The top lines on this graph, which are all the React-based methods, are consistently way ahead of the pack. Grounding its thinking in actual facts just makes the AI way more accurate. So if we boil it all down, React gives us 3 massive wins. First, it's way more trustworthy. It's forced to check its facts, so hallucinations go way down. Second, it's more interpretable. You can literally read the AI's train of thought and see how it got to an answer. No more black boxes. And finally, it's just more robust. It can recover from mistakes, something that used to stop other models dead in their tracks. And all of this leaves us with a really fascinating thought to end on. React signals a shift from an AI that just generates text to an AI that can be an active agent, one that can reason, plan, and actually interact with the world around it. And that really makes you wonder, what happens next when AI doesn't just talk at us, but actively thinks its way through our world?